Hello, hello. Hey, sorry about that. My computer had some issues. Hopefully they're fixed now and I can type it right again. Alright, we're good. So I am back. Hello, sorry. How many people are actually here? I see a Kapati comment, but nobody's in yet. Hello, hello. Yeah, sorry. So basically, my pen stopped working and I tried to troubleshoot it, and then Windows Update went, and I sat here raging for about 15 minutes, so I apologize. This was very stressful for me as well. But we're gonna jump to it now. It seems like we do actually have some people in here. Hello, Tatum. Hello, Johanna. Hello, Andrew. And hello, maybe Mark. Well, hope you had a good nap, Anna. Hi, Liam. This might be a little above your level, Liam. The good news is, if you're watching this late, hey, it's on time. So there's that. Okay, so let's jump into this. Yes, Seth, you're in the right place. You look like quite the goober in your picture there. It's a very serious face. Alright, so let's jump into this. Let's start off with the quizzes. I just graded them. I put almost all of them in the grade book, but not all of them. First of all, people did brilliantly. Oh, I had made a document. Yes, I want to view that file later. So more stuff crashed. Good stuff. Alright, so on this quiz, most people did great on inverse trig. I would say a majority of what people did wrong is, whoops, that's not the thing I want. A majority of what people did wrong is not remember to put everything in parentheses, so to put the 2x minus 3 in the absolute value and to do, oops, square root of 2x minus 3 squared minus 1. Basically, not to put everything everywhere. To maybe put an x here instead, or that sort of thing. Also, the bottom one, the integral one, is usually the hardest. And what people messed up this time was that the function was 2x squared, or u was 2x squared, which means this was almost exactly du. So you had to do the negative inverse sine of 2x squared, or the inverse cosine of 2x squared. On the other version, there was a similar u problem where I put a 2x on top instead of a negative 4x, and you had to figure out it was 1/2 the inverse sine of x squared, or 2x squared plus c. And so, yeah, between the versions, that was by far the one with the most mistakes. As far as mistakes went, I allowed one little one and still gave 5s to people, so if you forgot your plus c this week, you got off. You got a 5 anyways, so that's feels good, I think, for a lot of folks, because there were a lot of people in that camp who messed up just a little bit. Okay, now down to the one that has like a C or D average in all the classes, which is this one. Alright, so first of all, a bunch of people did not read this word, tangent line, and tried to solve this differential equation. Some people solved it right. I remember like Janae Skinner, I think, did it right, and a handful of other people. But this was not a solve this differential equation sort of situation. This was a find the tangent line. So you just plug in the points, and you get 1 times 2 squared, or 2 cubed rather, and that's 8. So that was actually our slope in this one, and in the other one it was 7, I believe. And then you just do a point slope form with the point you're given. Y minus 2 equals 8 times x minus 1. Or y equals 8x minus 6. So in this one, it was a majority of people's problem was not reading the word tangent line. Especially in first period, a lot of people goofed that up. I think I did fewer chants in that class of I will not integrate a differential equation on the next quiz. I think fourth period got a lot of those chants. Our second one here, Euler's method. Here's like the tried and true method to get this right. And most people who did it right did this thing. They built this table, x, y, y prime, Delta y, although these could be the same category in this problem because delta y or delta x was 1. These are the same when delta x equals 1, and in this we're doing 2 subintervals from 1 to 3. And y new is our last category. And we're given 1, 2. We already know that the slope is 8 because like we figured it out over here. And so 2 plus 8 is 10, and that's our new y. Now, using our new y, and which is our estimation of what y is at 2, and the x value, which is 2, we plug it back into the function xy cubed, and we get 2 times 10 cubed, which is 2,000. And so the y new is y plus delta y, which is 2010. And so that is x at 3. It's just 2010. Whoops. So this was by far the most missed question, was this middle one. There's not much to talk about in the slope fields. Almost everybody got 5s. So that's where I'm going to end this particular quiz. I don't have my comments open because I was all panicking to get ready here. So I'm going to pop back there and see what people are thinking. It's for baseball, chill out. Will this be on the test? Yeah, Euler's method will be on the test, yeah. When will quiz grades be posted? Well, Eric, it's only your class that does not have them posted. I just haven't finished second period. And second period did not do worse on this quiz, so feels good. I think first period had the worst grades on this quiz, as far as what I could tell by grading. So that feels good. Yeah, for second period. All right, I wanted to do the other Euler's method because a lot of people want me to do more Euler's method, and this had a completely different differential equation. Yeah, I know I have this. Let's open it. There we go. So, in this problem, I said the slope was 7, and the reason why is because 2 cubed minus 1 squared is 7. And then you just do y minus y1 equals slope times x minus x1, or 7x minus 5. And that's the tangent line. Remember, no integration needed, so a lot of people were like, there wasn't enough time on this quiz, and most of those people who did that tried to solve that differential equation. Which, by the way, this is not one we know how to solve. We have no tools to solve this yet. You'll take a class in college if you pursue math further. About how to do this problem. So rip anybody who tried to actually solve that differential equation. The other one was solvable, this one was not. Okay, now to Euler's method. X, y, delta y, or sorry, y prime and delta y, these are the same again in this problem because I'm giving you delta x's of 1. On the homework for this, delta x was like 0.1, and some of the examples we did in class that day had 0.1. But here they were the same. So I'm going to make them the same category. And y new. Okay, so x and y are 1 and 2. Our y prime is the same as here. It was so sad. A lot of people like found the slope on the left one and then like didn't use it on the right, or found the slope on the right one and didn't use it on the left. It's very sad, panda. 2 plus 7 is 9, so our new y new is 9. And so 2 and 9 are our next values in our table. We find a new slope slash our delta y for this question, and it is 9 cubed minus 2 squared. That's a 729 minus 4, or 725. I believe 729 is that cubed. Yeah. So then we add 725 plus 9, and we get 734, and that's our y for 3. 734. Some people win an extra step, but as long as you got the value at 3 right, I was good with it. You were just derping and you found the value at 4. A lot of people. I think Andrew was among those, if I remember right. But yeah, as long as you got here and built this table, I gave you the right answer on this. But yeah, all you're doing is building estimations based on the differential equation. So like this one is a tangent line, this first one that we find, but our second one is kind of a, best estimation curve. It doesn't actually touch our graph in most cases. That second estimation line. So it's no longer a tangent line, it's just an approximation of where we're going to end up. Yeah, let me zoom back to comments and see if I missed anything. Yeah, we weren't the worst. Yeah, true. What quiz sections are going to be on the tests? A lot of quiz sections, but notably, the big ones were the ones we just were talking about. So, all of these. Notably 33, 34, and then 35, which we have not quizzed on yet, but we've done a crud ton of in class, and it's something we're going to do some in this stream on, because it's very, very, very relevant to what's on the test. All right, so that's the quiz. Really, quiz scores were pretty good, especially in the first and third categories. I thought it was hilarious. Joey Ellis hasn't missed a problem in like weeks in the class, and then he messed up the slope fields. Feels bad. Okay, so not to call out anybody in particular. Oh my gosh, go away. So let's go to the review, and I had some questions in my early questions on the review, and so problem 1 was one of the questions. So I had this already, and I had opened up a Desmos document where I had graphed this thing, and then I had to restart my computer, so none of that is ready. So let's go to Desmos and graph this thing. So I had here, where's my keyboard? Oh, I got Desmos hooked up. Okay, maybe I don't have Desmos. Maybe I gotta put in the keyboard. I'm such a professional, holy smokes. Hopefully this doesn't mess up the pen again. Alright. So I go to Desmos, not teacher Desmos. That's where I build activities. And I graph this, it's v of t. And you can do this on your calculator more or less the same. On your calculator, a lot of what people are messing up is you actually have to type t times cosine t. If you just type in t cosine t, it does not graph it. And so that was, I know in class, something that was messing a lot of people up on that. And what's the last part of this? Minus natural log of t plus 2. I believe I got that right. Cool. Now from this we can make all the conclusions we need to. So starting off back at our document, we have where does the how many times does the object reverse direction? This is a velocity graph, and so I can see from 0 to 10 it goes through the axis twice. So that's why I didn't show any work. It's just like it's 2. It's this point 5.107 and this point 7.55. And yes, Desmos is better than the graphing calculators. For our second question, it was when does it reach its maximum speed? So we're looking for the maximum distance from the axis. And so that's like way down here at this critical point down here, which is right at the end of the interval. So 9.538. Remember, speed is the absolute value of velocity, so I was looking for farthest from the axis for that one specifically. And the total distance traveled, for distance traveled, you have to integrate the absolute value, so integrate the speed equation. And so what I did was just the integral of this v of t thing, which, again, pretty easy to do in Desmos. So it was 0 to 10 that I was doing this for? Yes. Cool. So I'm integrating from 0 to 10 of v of t. Whoops. The absolute value of v of t. Yes, throw in way too many absolute values. Good work, Desmos. Cool. And it's 39.039, which I believe is the answer I picked in my answer key here. Yeah, D there. All right, let me pop back and see how people are doing. Will 36 be on the test? He said one problem of 36. No, I said several 36 wait, 36 is differential equation. Oh, no. 36 is areas. Yes, 36 will be an easy question. What Eric said is correct on 36. So hopefully that answered people's questions. You're doing the same thing I'm doing in Desmos on your graphing calculator on that one. Just to review the answers in case you're watching this late and say you were watching this on silent. Let's go in and it was 2 times. It was 9.538 and it was 39.09. Yeah, go away. Oh, whoa, that's like what? All right. So the next question I got was 5 and 6 on here. So 5 was kind of fun because it was a sneaky related rates question. That's actually really easy if you can set it up right. So it says a particle's moving with this equation, but it also says that it's changing with respect to time because they give us units per second. So they give us dy dt. And so I know when I take the derivative of this, I'm going to get dy dt equals 1 over 4x plus 3 times the derivative of the inside, or the du that goes on top here is 4 dx dt. And I want dx dt, so I just plug in all of the points I know. I know the y-coordinate is changing at 12 units per second when the particle crosses the y-axis. So I know x is 0 because it's crossing the y-axis. So I know 2 things. I'm going to plug those in. 12 equals 1 over 3 because 4x x is 0 times 4 dx dt. I just 3/4 both sides, and I get 9 equals dx dt. Or multiply by 3 and divide by 4, and I get 9 for that answer. So that one's just a little sneaky with how to actually set it up and solve it. 6 is also a little sneaky. My work online showed this the way I like to think about it. I actually went and hollered at Kruzich after school, and she was helping somebody with this, and she was like, dude, this problem's dope. And I was like, yeah. So the integral of f is big F. If I plug in my bounds, I get big F of 6 minus big F of 0. So that equals 12, because it tells us that the integral equals 12. If I integrate this function, I'm also going to get big F, but instead of getting big F of 6x just by itself, because I have to do like u substitution or divide by the numerical chain rule, I actually get big F of 6x divided by 6 that I'm plugging 0 and 1 into. And when I plug in 0 and 1, I get big F of 6x, whoops, big F of 6, not 6x, minus big F of 0 over 6 because of this u sub chain rule thing. That's what makes these two different when I integrate them, because both of the f's are the same, but their insides cause me to deal with things differently. And the fact that the bounds are smaller. And from this, I get that I'm just going to get a sixth of the original problem's answer. So a sixth of 12, so it's 2. So that problem makes you think about it the same way we do the proof of the second fundamental theorem of calculus, where we turned it into big F's and we didn't even care if we could integrate the thing. We just said it's gonna be the integral of the thing. And then when we take the derivative, that's why we have to chain rule it out. So that's section 24, the second half, that a bunch of you are still retaking. That's that skill, and this tests an extremely similar idea to that skill. Like, what this is almost exactly the proof to that second fundamental theorem, which is why I do that. I think it's pretty useful. Let's go back and check the commons. Number 1 had a separate equation you wrote under it, derivative. Oh, did I mess something up? I put C? Oh yeah, that's wrong. 9.538 was clearly, from looking at the graph, the correct answer, so oops. Um, 5 does cross, Tom, the reason why 5 crosses the y-axis is because that log is shifted, if I remember right. Yeah, so this guy, to put a negative in here, you're right to think that logs don't go through the axis, but this guy's shifted a tad from the stretch in there. And so what would make this 0 is -3/4. And so this is where my logarithm starts. So it does actually pass through the y-axis because of that -3/4 starting point on this guy. All right, so I'm going to, well, actually, is that the end of my questions? Some people wanted me to do more diffie-qs. I'm going to let chat catch up with me and give me some direction as to where I should go on this. On number 5, I separated the variables and plugged 0 and 12 and got it right. Is that lucky demon magic, or is another way to do it? You separated the variables. Separated the variables. Krista, I'm trying to make sense of what you did. I'm trying to figure out what that means. In 5. Oh, did you get e to the y equals 4x plus 3 and then solve that thing? Because that would work. Andrew, I can absolutely do math. I have some questions ready that I was going to knock out. That's that other document that was like, do you want to save this? And I was like, heck yes. Can I do FRQ? Is that the potato question, Nicole? Oh, you moved the dx to the other side. Oh, yeah, that's totally legit, Krista. By doing that, Krista, you're showing that you understand that differential equations are like all integrals we've been doing. So that's totally legit. Yeah, it's why we do that in USub and so on and so forth. Okay, so yeah, these were going to be examples for me, so I was just going to knock some of these out. Just for giggles. Actually, Nicole had asked me a question. No, it's about population. Okay, so it wasn't the one we did in class. Yeah, let's go to that first before we go to my examples. Let's see, which one's about Oh, this one. Oh, sure, yeah, totally. I'm down to do this. Let's jump into this. So this is a very separable differential equation. I told some people this, but I got this off the BC exam. The second part of this was very doable for us. So to separate variables here, all I did was move the dt to the other side and move so I swapped these two, the y and the dt, by multiplying both sides by dt and dividing both sides by y. And so I get dy over y, it's a capital Y, whatever, man. Oh, jeez. Dy over y equals 1/5 times 1 minus t over 12 dt. The beauty of this is, like, people have asked me, like, you should do more Kecht problems. Well, this is more or less a Kecht problem here. So we integrate this just as is. Looks good. We got dy's on one side, we got dx, or all our t's on the other side, and we get natural log of y, absolute value, and it's a capital Y again. I'll get this through my head eventually. Equals, and the integral of this is 1/5 t, because this is a 1/5 times a 1, and then I add a t to it because I'm integrating. And then I subtract 1/5 times t over 12 is t over 60. And when I integrate that, I'm going to get t squared over 120 plus c. See, I could have simplified this ahead of time. 1/5 minus t squared over 60, and that's what I'm integrating. That might have been a good intermediate step there. But then I just e both sides, and my life gets easier. I just get y on this side, and on this side, I get c e to the negative 1/5 t minus t squared over 20, or 120. We have to solve for c, but we don't really have to solve for c, because when they give us a 0 condition, we have c. It's 3. That's a good thing. Cool. Now all it asks us is, for this thing, what is the limit at infinity of this? And all you have to do is think back to quiz 4. It's kind of the way I do why I do quiz 4 the way I do it. The dominant term is t squared. It is negative in here. Whoops, this was positive the whole time. Sorry if that was confusing you. But all that matters is that this guy is super negative. It's the dominant term because t squared is a lot bigger than t, even though it's divided by 120. And e to a really big negative number is 0. Exponentials to big negative exponents are not negative numbers. They are 0. It's something my Algebra 1 kids have a hard time with, and a lot of my calculus kids too, is that exponentials never yield negative numbers unless they're shifted down to yield negative numbers, or have a negative coefficient up here. But this guy with a positive coefficient and no shift, no minus like 10 on the outside or anything like that, can never be negative, and so this guy goes to 0. It's 3 times a 1 over a really big number, or times a really small number, which is 0. And that's that population one. Yeah, 1/5 isn't negative. Yeah, thanks, Seth. Alright, so I want to start looking at some of these. I was thinking we maybe go to the fun ones, but 2 starts off pretty good because it tells you in the question. It should look like a CE to the x, and negative 4xy is very family friendly. So let's. Oh, I have an example in there already. Well, you know what? Never mind. I have this example all rip-raring and ready to go based on questions I got online. So I kind of wanted to do all of the everything for this differential equation. I wanted to solve for a tangent line at some point, so let's make an initial condition. 2, 0. Seems like a good initial condition. Is that a good one? Nah, let's not do 0. It's an exponential function. Let's do 2, 2. Cool. That'll be my initial condition. I'm going to make a tangent line. I'm going to do Euler's method and estimate 4. Ooh, let's estimate 3 with 2 intervals. So then my delta y is going to be different than my y prime in this, because each of my widths are going to be a half, going from 2 to 3. And then I'm going to solve the differential equation for the last bit. So starting off with the tangent line, I'm just going to plug in 2 and 2, and I'm going to get my slope equals 8 over e squared. And then I just dump this into y minus y1 equals slope times x minus x1. Sick. Tangent line done. Now Euler's, yeah, this is going to be ugly because look at that gorgeous slope we have here. That thing is, if you want to be unintimidated by it, it's like pretty close to 1. E squared's like 7-ish. It's like 2.7 squared. So it's between 2 squared and 3 squared. It's not that evil. But yeah, we're going to use Euler's to estimate this. So I'm going from 2 to 2.5 to 3. In my x values, 3, the y value is what I want. So this is my x. My y's are going to be here, so I already know my y at my starting point. It's 2. I'm going to find my slope. I already know the first one. It's 8 over e squared. Maybe I should make this category bigger if the numbers are going to get really janky. I have my delta y, which is just going to be half of this, so 4 over e squared, but I'm going to have to figure it out for the other ones. And my last category is my y new, which allows me to dump the new value into the next spot. And so I do 2 plus 4 over e squared, and that's what goes here. Now to find my slope, my y is this hairy garbage here, so it's going to be 8 plus 4 over e squared on top, because 6 plus 2 in my original differential equation, over e to the 2.5. That's that slope. It means my delta y is half of this, because my delta x is 0.5, so I multiply my slope by my delta x to get my delta y. in case you're like sketched out about that whole delta y thing, all that comes from is the fact that delta y over delta x equals slope. So if I want to solve for delta y, I just multiply both sides by delta x, and I get delta y equals the slope times delta x. That's it. So it's not, this isn't demon magic, this Euler's method thing. There's no like crazy highfalutin stuff in here, it's just slope. Alright, I have this, so I get 4 plus 2 over e squared on top. I get e to the 2.5 on the bottom. And I add this to my original thing, so I get 2 plus 4 over e squared plus 4 plus 2 over e squared over e to the 2.5. And this garbage is my answer. And I did it. Like, you all thought this was going to get way too hairy, that I was going to give up. Nah, dude, this wasn't that hard. So we used 2 intervals of 0.5 thickness, that's why these were half of the slope, to estimate the value 1 over. And this is as hard as Euler's would ever be on a test, I think. I'm not sure it would ever get harder than this. Okay, so I'm going to dump back and see if there are any questions. He kind of went off on a tangent. Oh, come on, guys. People asked me to do math. And I did do a tangent. Gosh. That was the worst joke I've seen in a while. Alright, so I'm going to erase all this garbage and do a diffie q now. Because I kind of need some space here, so go away, Eulers. Kill it, kill it, kill it. Alright, cool. To separate variables in this one, I basically swap these. I say that a lot. I divide both sides by 6 plus y, I multiply both sides by dx. So I get dy over 6 plus y equals dx over e to the x. Now I'm not particularly happy with this, mostly because I don't like this e to the x on the bottom. Please do not integrate 1 over e to the x and get natural log of e to the x, or x. Because if that was true, it means the derivative of x is 1 over e to the x, which, if that's true, calculus is a lot harder than it is. So that would be a bummer. So the way we deal with this is we just make this e to the negative x dx. Not that horrible. Oh yeah, I was just moving to integrate this. Well, hold my horses here. Alright, so I integrate this, I get natural log of the absolute value of 6 plus y. No required u substitution here because it's just a single y on the bottom. Feels good. This derivative, negative e to the negative x plus c. Cool, so I have to e both sides. So I do that. I get 6 plus y equals e to the negative x, that's kind of exciting, and a c multiplied out front. If you're still mystified about the c multiplied out front thing, remember that e to the x plus c is the same as e to the x times e to the c, which is where that new c comes from. This is a new c, so maybe I should be listing that this is the old c, which it is. And then finally, I just get y equals c times e to the negative x. That's so fun to say. Minus 6. And now I have to solve for my initial condition. This might be jank as can be, so let's kill my tangent out of here and go solve for this. Yeah, get out of my way. All right. So I plug in 2. I get 2 equals c times e to the negative e to the negative 2 minus 6. Okay, so I add 6 to both sides. I get 8 equals c e to the negative 2. And then I just divide by this, so I get c equals 8 over e to the negative 2. And yeah, that's c, so my final answer would just be y equals this times e to the negative x minus 6. Yeah. The 6 is not multiplied by the c value. Yeah, so this is c times the crap here in this equation. And that would be a solved differential equation. Now I did this example that had a lot of jank in it, and this is harder than any of the versions of the tests that I have looked at as far as this problem would go. This problem I just did was an example free response question, and that is harder than anything you will get. I did all of the things. I did tangent, I did Euler's, and then I solved the differential equation. And it had some jank to it. Yeah, because we had e to the. That was kind of fun. Let's see how people are doing. Does anyone have a long dress that I could borrow? Oh, we are really doing great here. No blue, just got back from the farm now. Classic Ben. Yucky problem. Alright, let's do an easier one. What if point slope was in the FRQ? What would it replace? Ryan, I think you may mean slope fields? Slope fields would potentially replace Euler's, maybe? You probably always have to do a tangent line. But I know people can do slope fields because, like, the only people who messed up slope fields are people who thought there were zero slopes in places where there weren't actually zero slopes. Like, nobody actually messed up anything real. Like, no misconceptions, just goofy mistakes. Okay, so let's do one of these, because these will be nicer questions. So let's just jump in with, what looks nice? I think doing like a 7, like dy dx times secant of 4x equals -9 looks like a nice problem. Okay, come on. Oh gosh, is my button not working now? Feels bad. Alright, I can still click this. Alright, I am panicking again. My pen just crashed. Does this thing have batteries in it or something that are dying? Well, I just pulled the back off it. So that was probably not what I was supposed to do. But yes, indeed, there is a AAA battery in here. Well, hopefully it still has juice. If I fiddle with it. Rip Kennedy's pen. Actually, potentially rip. Now, it's possible I can just write with my finger to do some of these problems remaining. That may be the problem that I was having earlier that I restarted my computer and made this myself late for this for. What else could I do here? Where I have some other thing I can write in. Let's try this thing. And then I'll just put a problem in here and see if I can't write with my finger. Okay. I wrote with my finger a tiny bit. Alright, this is gonna work. It's gonna be super jerry-rigged. It's gonna look like garbage comparatively, but I ain't about trying to find batteries in my house right now. Alright, so let's make this a slightly bigger pen. Try my pen again. Nope, rip. Alright, so starting off, let's do y equals negative, or dy dx, whoops, equals -4xy. So this was the nicest example that was on that worksheet. And this is a classic, like, c e to the x one. Let's give myself an initial condition. Did they give me an initial condition? Yeah, I don't really care. Let's give myself an initial condition of 4, comma, e. Seems good. Maybe it'll suck. Who knows? Alright, so I get y is on one side, x is on the other, by dividing the y over and moving the dx to the other side, and I get dy over y equals -4x dx. I integrate both sides. And what I get is natural log of y in absolute values equals, okay, so this is negative 2x squared by dividing the negative 4 by 2 plus c. I just e both sides, and I get my classic sort of calc situation where I get y equals c e to the negative 2x squared. Now I need to find my c initial condition here, and I get e equals c times e to the negative 2e squared. Yeah, that's hideous. So yeah, my initial condition choice was questionable. So c equals e divided by e to the negative 2e squared. So that makes our final answer y equals e divided by e to the negative 2e squared times e to the negative 2x squared. And there are ways to simplify this to put things in the power, but meh. Like, seriously. I could add these powers so it could be e to the 1 plus 2e squared, and then I could add these powers and put the 1 plus 2e squared in this power. And maybe I'm going off the screen here, but I can put it in the power with the thing. But you don't have to on the AP test. They do not make you simplify that within the exponent that I've ever seen. Maybe on a multiple choice to match to the answer, but usually theirs aren't as janky as this. Yes, the back of the review is exactly like it. And Ben, to further that, do an example of that Half-Life BS if you're cruel enough to put it on the test. Oh, I'm absolutely cruel enough to put that sort of stuff on the test. Absolutely. So yeah, let's do one where you actually have to go through, because like the hard part in those is like the algebra, right? No, this is not what I want. Go back, go away. I want a new note. Cool. So let's do a new question here. Let's say it's just, we get a kect example from the get-go. So let's do half-life first. So y equals c e to the kt. All right. And let's give myself, what kind of question do we want to do for this? Let's say they give us the half-life. Half-life equals 1,200 years. Whoops, my fingernail is not as reliable. And, you know, how much after 500 years? This is not as good without the pen. But I have identified that my issue was a battery problem. All right. So, how much after 500 years? So, what I do in this question is, since I know this piece, basically in Half-Life questions, C doesn't matter at all. Because all you're going to do is figure out a proportion. So when I ask how much is there after 500 years, I'm really asking what proportion of what I started with is there after 500 years. So it's going to be greater than 50% because my half-life is longer than that, but I need to figure out exactly how much by solving this question. So what I do first is I set 0.5 equal to e to the kt. The reason I do this is because my y value that I want is 0.5c. I want the half-life. So when I divide c on both sides, I just get 0.5 equals e to the kt. And then all you do is, sorry, t is not correct here. I want to plug in, let's erase this garbage. I want to plug in 1,200 because that's how many years it takes to get half. So now I natural log both sides, and I get natural log of 0.5 equals k times 1,200. And then I divide by 1,200, and I know that the natural log of 0.5 divided by 1,200 is k. Now, there is an easier way to do this question. Some of you might be chomping at the bit to tell me it, but this is the kect way to do it. So now to find my proportion, all I do is say, okay, I want to find how much of my original I have if this is my k value after 500 years. So like what percentage? So I type in my k value, I put in 500, and now I just dump this into Desmos because my proportion, y over c, which is what percentage I have now compared to what I started with, y divided by c. If I divide how much I have now by how much I started with, I can find my percentage, is just going to be e to the natural log of 0.5 to the 5/12 power, it looks like. So let's figure out what that is. So where's e to the... Oh crap, I forgot what the problem was. Where was I doing this? Meow. So it is, okay, natural log of 0.5 to the 5/12. Or I could do this the non-cheaty way and just do 500 times natural log of 0.5. Nice, it does the function. Divided by 1200, or 12,000, whoop, 1200. And I get negative time. Oh gosh. Feels bad, man. Oh yeah, because I'm an absolute dingus, and I'm doing e to this power. Okay. Oh, okay, I gotta do it in here. Okay, e to the power of... There we go. This number, negative 0.288811. Okay, so we have about 75% of what we started with, is what we learned here. And so that could be a question. I could give something like that, where I ask you how much of it we have. If you're like, there's a shorter way, could you show that? I can do that. So the shorter way to approach these half-life questions is not to go to Kect. I mean, it kind of depends on the scenario and what you're doing. Let's say we're given this exact same scenario. Every half-life question, if you're given the half-life, is easier to do in this format that is like a pre-calc method, like a cheaty shortcut that doesn't involve any of our Kect tricks. We just say y is equal to our starting value times a half to the... whoops. What I was saying was correct. A half to the power of... And then you just do your number of years divided by your half-life. And so I could have just shortcutted and figured out I had 75% of what I was looking for by just doing that. And that would have also done it. So hopefully that answered people's questions on this. It should technically be over now, right? Yes. I am happy to go a full hour because I messed up. Today has been a tough day for technical difficulties. The pen went all like weird and half working, and then it just completely died. What do people want to see? Do people want to see like another type of word problem? Like I could do like a Newton's law of cooling sort of thing, or do we want to see like some sort of more challenging separating variables sort of thing, or do we want to see tangent, or do we want to see Euler's method more? What do people want? Related rates. I already did a related rates problem, Andrew. That was the question 5, the y equals natural log one. Related rates with integrals in it. More challenging separation of variables. Johanna, what was the first thing? I don't remember. Is there a key to the packet on your website? I think all that is on my website is the packet. Unless you're talking about a packet. Yeah, I think it's just... I think all I posted was the key. So, Johanna, if you clarify, I'm willing to look at it, but it seems like Eric and some other people are like separation of separation of variables is cool. Andrew, go away with the optimization. I don't want to do optimization. Let's do a different separation of variables one. So let's go to my worksheet I have here and pull one off of here. Let's do dy dx times secant 4x equals -9, because I talked about doing that one. Dy dx times secant squared 4x. I think it was secant squared. No, it's just a secant. Never mind. This could be exciting. Equals -9. Cool. So we just go to separate the variables. It's really tempting to leave the dx on the left side, but we absolutely cannot have the dx on the left side. We need to have our dy on top, and we need to have our dx on top. So I need to multiply the dx to the other side. Luckily, I can multiply both sides by cosine 4x, and it'll cancel the secant 4x, so I don't have a secant in my problem. So I just get dy equals -9 cosine 4x dx. And so this janky looking problem ended up being a lot nicer than we expected. Or at least than I expected. So we integrate both sides. We have a little bit of u sub here. U equals 4x. Du equals 4dx. So I have -9. So I have -9/4 du to be equal to 9dx. That's exciting. Or -9dx, rather. So what I get on this side is just y. What I get on this side is -9/4 times the integral of cosine of u du. And that integrates to -9/4 times sine of u, which is 4x, plus c. And we're done! Turns out this was a really easy differential equation. Joke's on you guys. The packet we just did. 3 or 4 on the packet. Okay. That's a good place to go to next after we just mobbed another differential equation like it was nothing. Oh gosh, can I even do these anymore? We'll do what we can. So 3 and 4 are these guys. Crud muffins. So the pen is dead, so I can't use those tools. Alright, so this question, I went over the test last class, so if you were there, we did quite a few problems like this. All I do for these problems is I would use a calculator again for this sort of thing, because I'm doing an integral. Oh, I guess I don't need a calculator because this is very integrable, but a calculator would make this a lot easier. What I do is I know the volume is 1.3 at t equals 1, and then I integrate from 1 to 5 of my rates in this question. And I add that to 1.3, and so that was 3 point something. I forget which of the answers it was. That was it. So it's extremely similar to a lot of the problems off the last test. And then this was a separable differential equation. This 4 seems like a great question to do, actually. Let's do that. Unless there's a lot of battle. Before you end the stream, can you show us all those problems you made, but like zoomed in? Well, I didn't exactly make those. I just kind of Googled separable differential equations, Eric, and just found some worksheet. Let's solve this differential equation the hard way instead of it being this stuff and finding the tangent line, because the tangent line's boring, and solving this differential equation looks like exciting. So, I can use the snipping tool with my finger and snip this. So I get it. Oh, come on, man. Here, let's go. New Sick. Edit, copy, and let's get a new one of these. And edit, paste. Cool. All right. So let's actually solve this differential equation, because this one looks spicy. So I got to separate variables here. I start off by just saying, hey, there's a y on both sides. Let's divide by y on both sides. So I just cancel those out. Then I'm going to move the 4 minus y to the left side, cubed, and move the dx to the right side, and I get 3 dy over 4 minus y cubed. Oh yeah, this is a good one to do. Equals 2x dx. I'm more or less ready to roll. Now, I could do u sub here for the 4 minus y, or you could just know that the derivative of negative y is negative 1, and I'm dividing by negative 1. Which means my answer is just going to be negative of this garbage. Okay, I'll rewrite it a little bit. Let's do 3, whoops, not over. I want to get rid of my fraction. That was the whole point of rewriting it here. I'm going to write this as 3 times 4 minus y to the negative 3. Why I might rewrite it as this is because a lot of people are super duper 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 tempted to kill ocelots and get a natural log of 4 minus y cubed here, which it's absolutely not. We only get that in 1 over u situations, and this is not that. It's 1 over u cubed, and so we're actually raising the power by 1. Whoops. Why did I draw the integral sign? Because I'm a dummy. Divided by the new power. And then divided by a negative 1 for the chain rule. And that's equal to x squared plus c. So that's a mess on the left side. Luckily, the bottom's just 2, so I can multiply both sides by 2/3 to undo the numbers out in front, and I can get that 4 minus y to the negative 2 equals 2/3 x squared plus c. Now I'm going to negative 1/2 power both sides, because that, if I multiply this by negative 1/2, it makes it 1, which is what I want it to be. So I get, whoops. I get 4 minus y equals 2/3 x squared plus c to the negative 1/2 power. And lastly, I got to solve for y. That was like the whole goal of this. So I get negative y by subtracting 4 on both sides. I get negative y is equal to 2/3 x squared plus c to the negative 1/2 minus 4. And then I multiply by a negative, so it's actually 4 minus this garbage. Whoa, this problem is spicy. And we have an initial condition that when y equals 1, when x equals 1, y equals 3. So I'm going to get rid of all this so I actually have room to type with my fat fingers. I need a bigger eraser. Oh, I'm on large already? Okay. So, come on, tool. So I need to solve for c, so I plug in 3 equals 4 minus... Okay, so I want this parentheses to be 1. I know that now. So 2/3 plus c to the negative 1/2 power. Well, turns out 1 to any power is 1. So if I want to solve for where that parentheses is 1, c's got to be what makes that parentheses equals 1, which is 1/3. That's a get hooked up sort of situation there. And so our final answer is just y is equal to 4 minus this garbage, 2/3 x squared plus 1/3 to the negative 1/2 power. And yeah, that problem was very exciting. That was a lot of fun. That was a good one. Let's see if people thought that was fun. Can you not increase the eraser size? This is kind of painful to watch. I agree. Holy smokes, dude. Oh yeah, so if you want to solve for the tangent line, like actually do the problem in the packet, all you do is I can't write on the page, but so let's go back to where I did all this garbage here. Here, all you do is plug in 3 for y and 1 for x, and you get 9 dy dx equals, and then whatever this crap is. So 6 on top and a 1 on the bottom. Cool, that was easy. dy dx is 6. What? 6 over 9? Oh gosh, that seems unlikely. You know what? I'm rolling with it. I'm assuming that's the right answer. Oh, 6/9 is 2/3. It is. It is D. Oh, feels good. All right. All right. So we have elapsed for about an hour. I am sorry about the technical difficulties. This is a really exciting day. Thank you, Windows Update, and my AAA battery in my pen for dying today and making today needlessly stressful. I want to thank all of you for showing up and asking me questions. I hope I answered most questions. Is the test mostly diffy-Qs, Ryan? Mostly might be a stretch, but there are diffy-Qs on it. I would say definitely more than half the points on the test are related to diffy-Qs. Are the 3 quiz sections in this chapter: slope fields, tangent lines and Eulers, and solving differential equations is definitely more than half. And the lagging wasn't nearly as bad this time. Yeah, I did my speed tests for my network, and I was getting 10 megabits per second upload, and it said it would be cool. So I'm hoping that was accurate. I pay for 10 megabits per second upload, so. You don't know what to study anymore. Andrew, you should study differential equations. If you're really good at those, you're probably going to do well on this. Otherwise, it's the same stuff off every other test. So if you want to come in and look at your old tests, because guess what? There's probably going to be a freaking limit definition of the derivative problem. There could be a related rates. There was on our review packet, so that's a potentiality there. Yeah, any of that stuff is definitely a possibility. Can you come in Monday after school? Absolutely, Ryan. Totally. And yeah, Seth, a diffy-Q is a differential equation. That's just a college shortcut. And yeah, any of you can come in Monday after school. I got Smash Club. I'm meeting a buddy afterwards in Renton, so I'll leave around 4:30. That's my goal for tomorrow. And second period, your quizzes are going to go in tonight. I'm just going to do it after I finish this. Kennedy, I'll come in during yearbook tomorrow. Okay, I'll try to get the tests created before then, so I don't have to do it after school, and I can work with people, because that would be a good thing. Any other questions or anything? Yeah. Classic Seth trolling me here. This is good. It's very good. Basically, if you knew Monday night's homework and you could do Friday night's homework, you should be in totally killer shape. I would honestly say Monday night's homework was more applicable to the test than even Friday night's homework was, the review for the test. I would call that as valuable, if not more valuable. Alright, cool. I'm glad it was helpful despite all the technical difficulties, and lucky you guys showing up late, if you're even still watching this, if you show up late. Yeah. Have a nice day, everyone. I'm going to go put in quiz grades and then probably play a little bit of video games, because, yeah, that's relaxing.